This is section 3.2, part B, residuals and the least squares regression line. In most cases, no line will pass exactly through all the points in a scatter plot. Because we use the line to predict y from x, the prediction errors we make are errors in y, which is the vertical distance in the scatter plot. A good regression line makes the vertical distances of the points from the line as small as possible. In section 3.1, we explored the relationship between body weights and backpack weights of a group of 8 hikers. Here are the data again. So we had the body weight and we had the pack weight. We made a scatter plot, and then we had a regression line. In the figure, we have a scatter plot with our regression line added. The predicted errors are marked as bold segments on the graph. The vertical deviations represent leftover variation in the response variable after fitting it to the regression line. These are called the residuals. So the amount left from where the plot point is back to the line is called the residual. So a residual is the difference between an observed value of the response variable and the predicted by the regression line. So to find your residual, you're going to do your observed y minus your predicted y, or y minus y hat. We need to find and interpret the residual for the hiker whose weight is 187 pounds. Now to do this, we first have to have our regression line. Our regression equation is given to us here, so we know that y hat is equal to 16.3 plus 0.0908 times the body weight. So first we're going to find your y hat. So you're going to plug in the body weight of 187 pounds. And you are going to get a predicted pack weight of 33.28 pounds. To find your residual, you're going to do your observed minus your predicted. Now, for the person who weighed 187 pounds, their observed pack weight is 30 pounds, where the predicted was 33.28. So that means that our residual for this person would be negative 3.28 pounds. The regression line over predicted the hiker's pack weight by 3.28 pounds. So when you take your AP exam, there's no firm rule for how many decimal places to show when you're answering questions. Our advice is to give your answer correct 2 or 3 non-zero decimal places. The exceptions for this are if you're using one of the tables in the back of the book, then you need to give all the values that are shown in the table. So the regression line we want is the one that minimizes the sum of the squared residuals, because the residuals are going to be negative and they're going to be positive. Those are going to cancel out, just like when we were finding standard deviation. So we're going to square the residual amount as we add them together, and we want to have this as small as we possibly can. That's what the line shown below does for the hiker data, which is why it is called the least square regression line. The least square regression line of y on x is the line that makes the sum of the squared regression residuals as small as possible. Now we can do this on your graphing calculator. To do this, you're going to enter your explanatory variable into list 1, your response variable into list 2. You need to hit mode and go down to Stat Diagnostics and make sure it is turned on. Then you're going to click Stat, go over to Calculate or Calc, and select Linear Regression A plus BX. Make sure the X list is L1, the Y list is L2. You're going to go down and to where it says Store Reg Equation, and then you'll hit vars, go over to Y vars, select Function, and then select Y1. You're going to hit Enter, and it will pop up with the equation of your regression line, or your least squares regression line, and it will tell you your R value or your R correlation. If you go to your graph, it will actually show your graph and the line on your scatter plot. So let's check our understanding. It's time to practice your calculator regression skills. Use the familiar Hiker data that is found below and find the equation of the regression line. So to do this, you're going to go to your list once. You're going to go Stat, Edit. Make sure you clear out list 1. In list 1, you're going to put the body weights. Then go over to list 2, and you clear out list 2. To do that, you can highlight list 2. You can hit clear and enter, and it will erase all data values in list 2. And then you're going to input all of the pack weights into list 2. Once this is done, you do need to go to second Y equals and select stat plot 1. You need to turn the stat plot on and make sure it's a scatter plot. Then you are going to hit Stat, go over to Calculate, select Linear Regression A plus BX. Again, make sure your X list is L1, make sure your Y list is L2, go down to Store Reg Equation, hit vars, go over to Y vars, select Function, then select Y1, hit Enter, and it should pop up with your regression. It'll tell you your A value, and it will tell you your B value, and it'll tell you the form of your equation. So it's going to pop up and say y is equal to A plus BX, and it's going to tell you A is 16.3 and B is 0.0908. You are going to have to put it into the equation yourself to get that y hat is equal to 16.3 plus 0.0908